Introduction: the language of the stars. Have you ever listened to an astronomer and felt lost in the terminology? Words like quasar, nebula, or event horizon, beautiful but distant. Tonight, that changes. Welcome to the language of the stars. A cosmic dictionary whispered slowly, softly, and simply. In this journey, we'll explore 100 celestial terms, not through cold definitions, but through gentle explanations that carry you across galaxies and centuries. From black holes to moonlight, from Saturn's rings to the mysteries of dark matter, you'll learn not only what each word means, but why it matters in the grand story of the cosmos. Let your mind drift between the stars. No pressure, no rush. Just a calm invitation to understand the universe, one word at a time. This space for sleep. And this is where understanding begins. 1. Andromeda. Andromeda is the closest spiral galaxy to our own, the Milky Way. Located about 2.5 million light-years from Earth. It contains over 1 trillion stars and is slowly moving toward us. But don't worry, this cosmic dance will take billions of years. Andromeda is more than a distant smudge in the sky. It's our galactic sibling. And one day, it will merge with the Milky Way, forming a new galaxy entirely. When you gaze into the night and catch a faint glow beyond the stars, you might just be looking at the future, a celestial union written across time. 2. Black hole. Black hole is a region of space where gravity is so strong that nothing, not even light, can escape. Formed from the collapse of massive stars. It's a point of no return, the event horizon. But black holes are not just destroyers. They sculpt galaxies. They shape the evolution of stars. They bend space and time like a river around a rock. Imagine an invisible presence, silent and motionless, yet capable of swallowing stars whole. Black holes remind us how mysterious and powerful the universe truly is. 3. Light year. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. It's not a measure of time, but of space. When we say a star is 10 light-years away, we mean its light has traveled for 10 years to reach your eyes. You're not seeing it as it is, you're seeing it as it was in the cosmos. Distance is memory. Every night sky is a gallery of time capsules. Each light year, a whisper from the past. 4. Asteroid. An asteroid is a rocky object orbiting the sun, smaller than a planet, but larger than a meteoroid. Most are found in the asteroid belt between Mars and Jupiter. Some are ancient leftovers from the birth of the solar system. Others have wandered near Earth, reminding us of the fragility of our world. They may seem insignificant, but asteroids hold secrets, clues to how planets formed, and even to how life began. In the quiet drift of a tumbling rock, there may be a story, billions of years old. 5. Atmosphere. An atmosphere is the layer of gases surrounding a planet. Earth's atmosphere protects life, traps heat, and gives us the air we breathe. But other worlds have atmospheres too, some thick with carbon dioxide, others with methane or sulfur clouds. On Titan, Saturn's moon, the atmosphere is so dense that it rains liquid methane. An atmosphere is a planet's skin, invisible, vital, mysterious. It tells a story not just of chemistry, but of climate, habitability, and, perhaps, life. 6. Aurora. An aurora is a natural light display in the sky, often seen near the polar regions. It happens when charged particles from the sun collide with Earth's magnetic field. These glowing curtains of green, red, and violet shimmer and dance. Across the night, a silent performance powered by solar winds. To ancient civilizations, they were omens or messages from the gods. To us, they're a reminder that Earth is alive and deeply connected to the star that warms it. When you see an aurora, you're witnessing the sky's way of breathing. 7. Big Bang. The Big Bang is the leading theory of how the universe began. A sudden expansion from a single, dense point about 13.8 billion years ago. It wasn't an explosion in space. It was the birth of space itself, time, matter, and energy, unfolding into what would become galaxies, stars, and us. Even now, the universe continues to expand. The afterglow of that moment still echoes as cosmic background radiation. The Big Bang is not just how it all started, is something instead of nothing. 8. Binary star. Binary star is a system of two stars that orbit a common center of gravity. They may appear as one from afar, but they are locked in a gravitational dance. Some are close enough to exchange matter. Others orbit at great distances, circling each other slowly across millennia. Binary stars are more common than you might think. In fact, most stars in the universe come in pairs, in a way. They remind us that even in the vast loneliness of space, companionship is a cosmic constant. 9. Boson. Boson is a type of fundamental particle that carries forces. Unlike matter particles, bosons are what make interactions possible. Photons are bosons. They carry light. Gluons hold atomic nuclei together, and the Higgs boson gives mass to everything that has mass. They're invisible weightless messengers, shaping the universe without ever being seen directly. Bosons are the quiet engineers of the cosmos. They don't build the stars. They make sure the stars can shine. 10. Galactic Arma. Galactic arm is one of the spiral-shaped regions extending outward from the center of a galaxy. There, where stars are born in thick clouds of gas and dust, our solar system lies within one. The Orion Arm. Not too big, not too small, just a quiet stretch of cosmic suburbia. These arms are not fixed. They swirl and evolve like waves frozen in time, graceful curves holding billions of suns. Galactic arms are the fingerprints of spiral galaxies, and everyone is a masterpiece in motion. 11. Asteroid Belt. Asteroid Belt is a vast region of space between Mars and Jupiter, filled with rocky fragments left over from the early solar system. It's not densely packed. You wouldn't dodge asteroids like in the movies. Instead, these silent travelers orbit peacefully, scattered across millions of kilometers. Some are tiny, others hundreds of kilometers wide. They may be the remains of a failed planet, or the ingredients of one never formed. The asteroid belt is a cosmic archive holding memories from the solar system's earliest days. 12. Kuiper Belt. The Kuiper Belt is a distant ring of icy bodies beyond Neptune. It's home to dwarf planets like Pluto and many frozen relics from the formation of our solar system. Unlike the asteroid belt, it's made mostly of ice, water, methane, ammonia, frozen in deep, cold darkness. It marks the edge of what we once thought was the end. But beyond it lie even greater mysteries. The Kuiper Belt is a frozen frontier, a reminder that the solar system doesn't end where the light fades. 13. Comete. Comet is a small, icy body that orbits the sun when it gets close enough. Sunlight causes it to release gas and dust, forming a glowing tail. Comets come from the deep, from the Kuiper Belt, or even the distant Oort cloud. They're messengers from the edge, waking only when the sun calls them close. For ancient peoples, they were omens. 2 astronomers. They're time capsules holding secrets from before Earth even formed. A comet is the sky's fleeting memory, streaking across the night, then gone. 14. Constellation. A constellation is a group of stars that form a recognizable pattern in the night sky. They've guided sailors, inspired myths, and helped us map the heavens. There are 88 official constellations, from Orion the Hunter to Draco the Dragon. They are not real groupings, just stars that appear close from our point of view. But humans need stories, even in the stars. And constellations are our way of drawing meaning onto the infinite. Each one is a myth written in starlight. 15. Cosmology. Cosmology is the study of the origin, structure, and fate of the universe. It's not just astronomy, it's the philosophy of the cosmos. Cosmologist. Ask, where did everything come from? What is space made of? How will it all end? From the Big Bang to dark energy, cosmology traces the universe's life story. It is the science of wonder, an attempt to understand the totality of all that exists, and perhaps why it does. 16. Twilight. Twilight is the soft light that appears when the sun is just below the horizon, either before sunrise or after sunset. It's a time of transition when the world is not yet day and no longer night. The sky blushes in hues of blue, purple, and orange as shadows stretch and stars begin to peek through. Twilight is gentle, quiet, poetic. The cosmos softens its voice, and the earth, for a brief moment, holds its breath. 17. Star cluster. Star cluster is a group of stars that form together and remain bound by gravity. Some are young and bright, others ancient and dim. Open clusters are loose, like the Pleiades. Globular clusters are tight spheres of hundreds of thousands of stars orbiting the galaxy's core. They are families of suns moving as one through the darkness, a reminder that even stars don't always travel alone. To look at a star cluster is to see unity written in light. 18. Galaxy cluster. A galaxy cluster is a collection of hundreds or even thousands of galaxies, held together by gravity and dark matter. Each galaxy has billions of stars. Each cluster, trillions. They are the grand cities of the cosmos, dense, ancient, and sometimes colliding. In the darkness between them lies dark matter and energy, binding them in ways we still don't fully understand. Galaxy clusters show us the scale of the universe and how even the largest structures are part of something larger still. 19. Curvature of space. The curvature of space refers to how mass and energy bend the fabric of space-time, as predicted by Einstein's theory of general relativity. Space is not flat, it's flexible. A star, a planet, a black hole, each one makes a dent in it, like a heavy ball on a stretched sheet. Light follows that curve. And so do we. The curvature of space is how gravity works, not as a force, but as geometry. It bends paths, shapes, orbits, and guides galaxies in motion. 20. Cosmic density. Cosmic density is the average amount of mass and energy in the universe. It determines the shape, fate, and evolution of everything. If the density is high, the universe might one day collapse. If too low, it could expand forever. But current evidence points to something strange, a universe balanced near a perfect critical point, with dark energy accelerating its expansion. Cosmic density isn't just a number. It's the delicate scale on which the entire cosmos balances. 21. Exoplanet detection refers to the methods astronomers use to find planets outside our solar system, orbiting distant stars. We can't see most exoplanets directly. Instead, we detect their presence through shadows, wobbles, and subtle changes in starlight. The transit method watches for a star dimming slightly as a planet crosses in front of it. The radial velocity method detects tiny shifts in a star's motion, tugged by a planet's gravity. Each discovery is a quiet triumph, a new world hidden in the light of another sun. 22. Eclipsing eclipse happens when one celestial body moves into the shadow of another. On Earth, we see solar and lunar eclipses, breathtaking alignments of the sun. Light. A lunar eclipse happens when Earth casts its shadow on the moon. For moments, day turns to twilight, or the moon glows red like a forgotten ember in the sky. Eclipses remind us of cosmic precision, of orbits, shadows, and silent choreography. 23. Drake equation. The Drake equation is a formula that estimates the number of intelligent civilizations in our galaxy, capable of communication. It includes factors like the rate of star formation, the number of planets per star, and the chance of life evolving and developing technology. We don't know the values of many parts, but the equation itself asks the most important question: are we alone? It turns science into speculation and numbers into wonder. 24. Axis of rotation. The axis of rotation is the imaginary line around which a planet or moon spins. Earth's axis is tilted, which is why we have seasons. This tilt creates summer and winter, light and shadow, rhythm and change. Every planet has its own spin, and with it, its own cycles. The axis is a planet's silent backbone, holding time in balance, turning night into day. 25. Ellipson. Ellipse is a stretched circle, the shape of most planetary orbits. It's not perfectly round, but elongated, like a soft oval. Johannes Kepler discovered this shape in the 1600s, replacing the idea of perfect circles in the heavens. Ellipses bring us closer to how nature truly works, with beauty in imperfection and order in asymmetry. They teach us that orbits aren't fixed wheels, but graceful loops drawn by gravity's hand. 26. White dwarf. White dwarf is the remnant core of a star like our Sun, a small, dense object left behind after the outer layers have drifted away. It no longer burns fuel. It simply glows, slowly fading over billions of years. A teaspoon of white dwarf material would weigh tons. Its matter crushed to the edge of physics. These stellar embers are quiet tombstones of once living stars, softly shining in the night until they go dark. 27. Brown dwarf. A brown dwarf is something between a planet and a star. Too big to be a planet, too small to sustain fusion like a star. They glow faintly in infrared and drift quietly through space, often alone. They're called failed stars. But that's not fair. Brown dwarfs are their own kind of mystery. Strange. Twilight objects that blur the line between categories. They teach us that not everything in the universe fits neatly in a box. 28. Entropy is the measure of disorder in a system, a concept from thermodynamics that also touches the nature of time. Over time, systems move toward higher entropy, more chaos, less structure. Stars burn out. Ice melts. Galaxies drift apart. Entropy is why time flows forward, why the past feels ordered and the future uncertain. In the grand story of the cosmos, entropy is the silent clock, ticking toward a colder, darker universe. 29. Equinox. An equinox occurs twice a year when the sun is directly above Earth's equator, and day and night are nearly equal in length. They happen around March 21st and September 23rd. One marks the start of spring, the other of fall. For ancient cultures, equinoxes were sacred moments when balance returned to the world. Even today, they remind us of the Earth's steady rhythm, spinning, tilting, circling the sun. 30. Eratosthenes was an ancient Greek scientist who, over 2,000 years ago, measured the Earth's circumference using only shadows and math by comparing the length of shadows in two cities at the same time. He calculated the planets' size with remarkable accuracy. No satellites, no telescopes, just curiosity and reason. Eratosthenes showed us that even from Earth, we can understand the cosmos if we're willing to look, think, and wonder. 31. Celestial sphere. The celestial sphere is an imaginary sphere that surrounds Earth, onto which all stars and planets appear to be projected. Ancient astronomers used it to map the night sky, placing constellations, tracking motions, predicting eclipses. Even though it's not real, this sphere helps us understand the sky as we see it from Earth, a dome of stars rotating overhead. It's a reminder that even illusions can guide us, as long as we look up with wonder. 32. Electromagnetic spectrum. The electromagnetic spectrum is the full range of light, from radio waves to gamma rays, visible and invisible. What we see with our eyes is just a tiny sliver. The universe speaks in wavelengths we cannot sense, but telescopes can dot infrared, reveals cold dust. Ultraviolet shows starbirth. X-rays expose cosmic violence. The spectrum is the universe's voice, and astronomy is learning to listen. 33. Space station. A space station is a structure in orbit where humans can live and work in microgravity. The most famous today is the International Space Station, or ISS. It orbits Earth every 90 minutes, a laboratory among the stars. Astronauts float through narrow modules, growing plants, testing physics. Watching Earth spin below, the space station is a stepping stone from our blue planet to the stars beyond. 34. Star. A star is a massive ball of burning gas, held together by gravity and powered by nuclear fusion in its core. Stars are born in clouds of dust and gas. They shine for millions or billions of years and end as white dwarfs, neutron stars, or black holes. Every night when you look up, you're seeing suns, some young, some ancient, each one a fiery beacon in the cosmic dark. 35. Neutron star. Ray. Neutron star is the collapsed core of a massive star, incredibly dense, spinning fast, and only about 20 kilometers wide. A teaspoon of its matter would weigh 1 billion tons. Some neutron stars pulse beams of energy. We call them pulsars. They rotate dozens or hundreds of times per second. They are the frozen hearts of former stars, beating quietly at the edge of physics. 36. Exoplanet. An exoplanet is a planet that orbits a star outside our solar system. Thousands have been discovered. Gas giants, rocky worlds, even Earth-like candidates. Some orbit twin suns. Others are scorched by heat or frozen in darkness. Each one is a possibility, a place where oceans might shimmer, or clouds might drift across alien skies. Exoplanets remind us that Earth is not unique, just one among many. 37. Lunar phase. Lunar phase is how the moon appears from Earth as it orbits us, changing shape from new moon to full and back again. It takes about 29.5 days for the cycle to complete. These phases are caused by sunlight hitting different parts of the moon's surface, from sliver to glow, from shadow to silver plate. The moon's phases mark time for calendars, for tides, for dreams. The moon is our nearest companion, changing face but never leaving. 38. Photon. Say photon is a particle of light, the smallest unit of electromagnetic energy. It has no mass, no charge, and travels at the fastest speed in the universe. Photons let us see the stars. They heat the earth. They carry messages across galaxies. A photon is born in the heart of a star, travels for millions of years. 39. Galaxy. A galaxy is a vast collection of stars. Gas, dust, and dark matter, bound together by gravity. The Milky Way is our home galaxy. Andromeda is our neighbor. Some are spirals, others ellipticals, some irregular and wild. There are hundreds of billions of galaxies, each one with billions of stars, and each star with a chance of planets, and each planet a question. Galaxies are the grand islands of the cosmos. 40. Elliptical galaxy. Elliptical galaxy is a type of galaxy with an oval or spherical shape, lacking the spiral arms seen in galaxies like the Milky Way. They often contain older stars, little gas or dust, and few signs of new star formation. Elliptical galaxies range from tiny dwarfs to giants that dominate clusters. They are quieter, older, more massive cosmic relics shaped by ancient collisions and slow fading light in their stillness. They tell stories of a past long gone. 41. Spiral galaxy. A spiral galaxy is a galaxy shaped like a flattened disk with arms that wind outward from the center, like a pinwheel. The Milky Way is one. So is Andromeda. These galaxies are rich in gas and dust, active nurseries where stars are still being born. Their graceful arms shimmer with starlight, each spiral a frozen wave of formation, motion, and time. Spiral galaxies are some of the most beautiful structures in the cosmos, organized, dynamic, alive. 42. Irregular galaxian. Irregular galaxy has no defined shape, no spiral arms, no central bulge. It's a cloud of stars scattered like stardust. They often form when galaxies collide or are disrupted by gravity. Though they seem chaotic, irregular, galaxies are still places of star birth, and sometimes contain hidden order beneath the randomness. They remind us that not all beauty is symmetrical, and not all galaxies need structure to shine. 43. Geocentric means Earth-centric means Earth-centered. An ancient model where Earth was believed to be the center of the universe. For centuries, this view dominated science, religion, and philosophy. The sun, moon, and stars were thought to revolve around us, but eventually, the heliocentric model replaced it, putting the sun at the center. Still, geocentrism reminds us how human perspective can shape understanding, and how science grows by letting go. 44. Gravity. Gravity is the force of attraction between masses. It's what keeps planets in orbit, holds us to the ground, and shapes the universe. Newton described it. Einstein redefined it. Gravity bends light. It curves space. It sculpts galaxies. Though invisible, its presence is everywhere, in every fall, every orbit, every heartbeat of the cosmos. Gravity is the quiet architecture of existence. 45. Galactic halo. The galactic halo is a spherical region surrounding a galaxy, containing old stars, globular clusters, and dark matter. Though it's dim and diffuse, the halo may hold clues to a galaxy's origins. It's where time slows down, where ancient stars drift in silence, invisible but massive. The halo binds the galaxy together, a ghostly skeleton of gravity and memory. In the darkness beyond the spiral arms, the halo keeps watch. 46. Heliosphere. Heliosphere is the vast bubble around the sun, created by solar wind pushing against interstellar space. It's a shield, protecting the solar system from cosmic radiation and particles. The edge of the heliosphere is far beyond Pluto. Voyager 1 crossed it in 2012, becoming the first human object to enter interstellar space. The heliosphere is the sun's invisible breath, carving a space for us inside the cosmic sea. 47. Event horizon. The event horizon is the boundary around a black hole, the point beyond which nothing can return, not even light. It's not a surface, but a limit, a veil over a place where space and time dissolve. To cross it is to vanish, not destroyed, but no longer seen. Event horizons remind us that even light has limits, and that some mysteries are hidden not by distance, but by nature itself. 48. Hubble telescope. The Hubble Space Telescope is one of the most important observatories ever built, launched into orbit in 1990, free from Earth's atmosphere. It captures images of incredible clarity, galaxies forming, nebulae glowing, the deepest reaches of space. It has rewritten textbooks and opened imaginations. Hubble is more than a telescope. It's a lens into time, and a symbol of humanity's longing to understand the stars. 49. Cosmic inflation. Cosmic inflation is a theory that the universe expanded extremely rapidly in the first fraction of a second after the Big Bang. This sudden growth smoothed out the cosmos, explaining why the universe looks the same in all directions. It was brief but immense, stretching quantum fluctuations into the seeds of galaxies. Inflation is a cosmic whisper, an echo of how everything came to be. 50. Interferometer is a technique that combines light, or radio. Waves from multiple telescopes to act as one giant instrument. It increases resolution, letting us see fine details. Like the shadow of a black hole, the event horizon. Telescope used this method to image M87's black hole in 2019. Interferometry teaches us that clarity doesn't always come from size, but from unity, many eyes seeing as one. 51. Jupiter is the largest planet in our solar system. A gas giant so massive that it could fit over 1,300 Earths inside. It's known for its swirling clouds, colorful bands, and the Great Red Spot, a storm larger than our entire planet. Jupiter has dozens of moons, some with oceans beneath their icy crusts. Its gravity shapes orbits, protects Earth from comets, and anchors the balance of the outer solar system. Jupiter is a silent guardian, massive, majestic, and ancient. 52. Lake Laika was a stray dog from Moscow and the first living creature to orbit Earth. In 1957, aboard Sputnik 2, she was launched into space by the Soviet Union. She never returned. Laika's mission paved the way for human spaceflight. But her story is also one of sacrifice. She looked out from her small capsule at a world she'd never understand. Yet, she became part of its history. Laika reminds us that exploration often begins with courage, and sometimes with sorrow. 53. Lenticular galaxy. Lenticular galaxy is a blend between a spiral and an elliptical galaxy, a disk without arms, smooth and faded with age. They are often found in clusters, their stars old and quiet, their gas mostly gone. These galaxies are caught between eras, once active, now passive. Lenticular galaxies whisper of transformation, of motion slowing down, of stars settling into silence. 54. Zodiacal light. Zodiacal light is a faint, triangular glow that appears in the sky before dawn or after dusk, caused by sunlight scattering off dust in the inner solar system. You can see it in very dark places, a soft beam rising from the prosit horizon pointing toward the stars. Ancient skywatchers believed it was spiritual, a staircase of light reaching the heavens. Today, it's a reminder that even cosmic dust, the smallest debris left from creation, can still reflect something beautiful. 55. Magnetara. Magnetar is a type of neutron star with an extremely powerful magnetic field, 1 trillion times stronger than Earth's. It can distort atoms, affect space-time, and emit bursts of gamma rays strong enough to alter satellites. Magnetars are rare, intense, and short-lived. They are cosmic pressure points where physics bends, and even the strongest forces tremble. Tiny, deadly, mysterious. They are among the most extreme objects in the universe. 56. Mass is the amount of matter in an object, a fundamental property that determines how much gravity it exerts. It's not the same as weight, but mass shapes how things move and interact. From grains of dust to stars, from planets to galaxies. Mass is what holds the universe together. Even light, though massless, is affected by it. Mass is invisible, yet everywhere, the quiet heart of physical existence. 57. Dark matter. Dark matter is a mysterious substance that makes up about 27% of the universe. Yet, we cannot see it, touch it, or detect it directly. We know it's there by the way it bends light and holds galaxies together. Without it, stars would fly apart, and cosmic structure would unravel. It neither emits nor absorbs light. It simply hides. Dark matter is the universe's unseen architecture, real but elusive. 58. Celestial mechanics. Celestial mechanics is the study of how celestial bodies move, how planets orbit, moons dance, and gravity weaves its patterns across space. It began with Kepler and Newton, and continues today with space probes and planets. It's math and elegance, the music of the spheres. Played in silence, to study celestial mechanics is to read the hidden choreography of the cosmos. 59. Mercury. Mercury is the closest planet to the Sun, a scorched, cratered world of extremes. It has no atmosphere to speak of, and temperatures swing wildly between day and night. Its surface resembles the moon, but its core may still be partially molten. Mercury is fast, the swiftest planet in the solar system. Its year is just 88 Earth days, small, ancient, and mysterious. Mercury is the Sun's closest companion. 60. Meteorite. Meteorite is a fragment of rock or metal that survives its journey through Earth's atmosphere and lands on the surface. Once a meteoroid, it blazes as a meteor, and if it endures, it becomes a meteorite. Some are tiny, others have carved craters. Some are older than Earth itself. Meteorites are messages from space, falling stars you can hold in your hand. 61. Milky Way. The Milky Way is the galaxy we call home, a vast, spiral structure containing over 100 billion stars. We see it from Earth as a hazy band across the night sky, a river of light made from countless distant suns. Our solar system orbits its center every 225 million years, carried within one of its quiet arms. The Milky Way is more than our address in the cosmos. It's a reminder that we are part of something immense and beautiful. 62. Multiverse. The multiverse is a hypothetical collection of all possible universes, a reality beyond our own, where different versions of space, time, and laws of physics may exist. Some theories suggest infinite worlds. Others propose bubbles of space-time, each with its own beginning. There's no direct evidence, not yet, but the idea opens doors to vast imagination. If the universe is everything, then the multiverse is everything again and again. 63. Nebulae. Nebula is a cloud of gas and dust in space, a place where stars are born, or where they go to die. Some glow with the light of nearby stars. Others are dark, hiding new suns in their depths. Ned come in many shapes, pillars, veils, spirals, each a canvas of cosmic change. They are the breath of the universe, the glowing remnants of past creation, and the seeds of what's to come. 64. Neutrino. Neutrino is a nearly massless, chargeless particle that passes through matter almost without interaction. Trillions of them are streaming through your body right now, emitted from the sun, from stars, from distant supernova. They rarely collide with anything, ghosts of the particle world, but they carry vital clues about how the universe works and where it's been. Neutrinos are whispers from the heart of stars, heard only by the most sensitive instruments. 65. Nova. Nova is a sudden, powerful explosion on the surface of a white dwarf, caused when it pulls gas from a nearby star. This burst of energy causes the star to brighten dramatically, then fade again over weeks or months. Novas are not the death of a star, but a flare, a warning, a flash of instability. They are moments of drama in an otherwise quiet life, reminding us that even calm stars can surprise us. 66. Observable universe. Observable universe is the part of the cosmos we can see or detect, limited by the speed of light and the age of the universe. It stretches about 93 billion light-years across. Beyond that, there may be more, but we'll never know. What we can see is vast enough. Billions of galaxies, each with billions of stars. The observable universe is not the whole story, but it is the part we've been allowed to read. 67. Orbiton. Orbit is the path one object takes as it moves around another, like Earth around the Sun, or the Moon around Earth. Orbits can be circular or elliptical, stable or chaotic. They're shaped by gravity, but they express balance. A dance between falling and moving forward. Everything in the cosmos orbits something else. Nothing drifts without influence. Orbits are the poetry of motion. 68. Oort cloud. Oort cloud is a vast, distant shell of icy objects surrounding the solar system far beyond. Pluto, it's believed to be the source of long-period comets, those that visit the inner solar system only once every few thousand years. We've never seen it directly. It exists as a theory, inferred from what arrives unexpectedly. The Oort cloud is the solar system's farthest edge, a cold, quiet mystery wrapped in darkness. 69. Parallax. Parallax is the shift in position of a nearby object against a distant background when viewed from different angles. It's how we measure distances to stars, by observing them from different points in Earth's orbit. A star that seems to move slightly against the background is closer than one that doesn't. Parallax is the geometry of perspective, the way the universe lets us understand depth across impossible scales. 70. Penumbra. The penumbra is the lighter, outer part of a shadow, especially during an eclipse. It's not full darkness, but partial, where light is only partly blocked. During a lunar eclipse, Earth's penumbra softens the moon's glow. During a solar eclipse, it casts a dim shadow across Earth. The penumbra reminds us that not all shadows are complete. Some fade gently, leaving room for light to return. Parallax is the geometry of perspective, the way the universe lets us understand depth across impossible scales. 71. Perihelion. Perihelion is the point in a planet's orbit when it is closest to the Sun. For Earth, this happens in early January. Even though it's winter in the northern hemisphere, we are nearer to the Sun than at any other time. This closeness slightly increases solar energy, but seasons depend more on Earth's tilt than distance. Perihelion is a quiet moment in our orbit, a brief embrace with the star that gives us life. 72. Photon sphere. The photon sphere is a region near a black hole where gravity is so strong that light can orbit it, caught in a never-ending loop. Photons trapped here circle the black hole endlessly, forming a glowing ring that helps reveal the black hole's silhouette. It's not the event horizon, but it's just above it, a tight boundary between motion and stillness. The photon sphere is where light becomes lost in gravity's spell. 73. Planetary nebula. Planetary nebula is a shell of gas and dust ejected by a dying star, a glowing cloud marking the end of a star's life cycle. Despite the name, it has nothing to do with planets. It was so named because early astronomers thought they looked like small planets through telescopes. At its center, a fading white dwarf remains. Around it, a radiant halo expands into space. Planetary nebulae are final breaths, colorful, fragile, brief, and breathtaking. 74. Planetesimala. Planetesimal is a small object formed in the early solar system, a building block of planets. They collided, merged, and grew, forming protoplanets, and eventually full-fledged worlds. Though most were lost or absorbed, some still drift as asteroids or moons. They are ancient remnants, witnesses to the chaos of creation. Planetesimals were the first pieces of the cosmic puzzle, tiny but essential. 75. Plasma. Plasma is the fourth state of matter, a hot, ionized gas found in stars, lightning and fusion experiments in the sun's core. Plasma rages at millions of degrees, fusing hydrogen into helium and releasing light. It behaves like both a gas and a conductor, shaped by electric and magnetic fields. Most of the visible universe is plasma. It is the medium of stars and the matter of energy. 76. Pulsar. Pulsar is a rapidly spinning neutron star that emits beams of radiation from its magnetic poles as it rotates. These beams sweep across space like lighthouse beams, and if Earth lies in their path, we detect pulsars. Some pulsars spin hundreds of times per second. They are clocks of extreme precision, ticking through the darkness. The remnants of collapsed giants still echoing with energy. 77. Quantum fluctuation. A quantum fluctuation is a tiny, temporary change in energy that occurs even in empty space. Due to the uncertainty of quantum physics, particles appear and vanish in pairs, blinking in and out of existence like cosmic static. These fluctuations may have seeded the first structures in the universe, expanding during inflation to become galaxies. From almost nothing came everything. Quantum fluctuations are the soft tremors at the heart of reality. 78. Quasar. Quasar is the brilliant core of a distant galaxy, powered by a supermassive black hole consuming matter as gas falls inward. It heats up and emits incredible energy, sometimes outshining the entire galaxy around it. Quasars are ancient. Most come from the early universe, billions of light years away. They are cosmic beacons, lighting up the darkness of the young cosmos, a sign of galaxies taking shape. 79. Radiation pressure. Radiation pressure is the force exerted by light or electromagnetic radiation when it hits a surface. Though photons have no mass, they carry momentum in stars. Radiation pressure pushes outward, balancing the inward pull of gravity and keeping the stars stable. It's also what drives solar sails, letting spacecraft move through space, pushed by starlight alone. Light isn't just illumination. It can move, push, and build. 80. Red giant. Red giant is a late stage in a star's life when it expands and cools. after exhausting the hydrogen in its core. The sun will become one. Billions of years from now, growing so large it may swallow Mercury and Venus, despite their name. Red giants glow orange and yellow. They're luminous, bloated, and nearing their final act. Red giants are stars in transition, beautiful and vast, on the edge of letting go. 81. Redshift. Redshift is the stretching of light toward longer wavelengths, the red end of the spectrum, caused by an object moving away. It's how we know the universe is expanding. The farther a galaxy is, the more its light is shifted. Redshift is a silent clue, a fingerprint of motion left in starlight. It lets us look back in time, measuring distance with color and velocity with silence. 82. Relativity. Relativity is Einstein's theory that space and time are woven together, and that gravity is the bending of this fabric. Time slows near massive objects. Light curves through space. Motion and stillness become perspectives. Relativity reshaped our view of reality. It made the universe more strange and more beautiful. It tells us that the cosmos is not fixed, but fluid, curved, and deeply connected. 83. Roche limit. The Roche limit is the minimum distance a moon or object can orbit a planet without being torn apart by tidal forces. Inside this limit, gravity stretches and shatters. Outside it, orbits remain stable. Saturn's rings may be made of moons that wandered too close and broke apart. The Roche limit is a boundary not of distance, but of survival. 84. Satellite. Satellite is any object that orbits another natural, like the moon, or artificial, like the ISS. Satellites observe Earth, navigate our world, study the stars, and whisper data across space. They float in precise paths, held by balance, neither falling nor flying away. Every night, a few pass overhead, quiet, distant, and watching. 85. Singularity. Singularity is a point where density becomes infinite, and the laws of physics break down, found at the center of black holes. It's where matter collapses into a point with no volume, but unimaginable mass we cannot see or understand. It's a riddle at the heart of gravity. A singularity is where knowledge ends and mystery begins. 86. Solar flare. Solar flare is a sudden eruption of energy from the sun's surface, releasing light, heat, and charged particles. These flares can disrupt satellites, cause auroras, and affect Earth's magnetic field. They come from twisted magnetic fields snapping back into place. Solar flares remind us that the sun is not calm, but alive, dynamic, and sometimes violent. 87. Solar system. The solar system is our home in space. A star. 8 planets, moons, asteroids, comets, and more, all bound by gravity. It began as a spinning cloud of gas and dust. Now, it is a dynamic family with inner rocky planets and outer giants. From Mercury to the Kuiper Belt, it's a story of formation, motion, and delicate balance. The solar system is not just where we live, it's where we began. 88. Solstice. Solstice marks the longest or shortest day of the year. When the sun reaches its highest or lowest point in the sky at noon. There are 2 each year, summer and winter. They are turning points, celebrated by ancient cultures with monuments, fire, and ritual. Solstices are the Earth's breath, inhaling light, then exhaling it again. 89. Space-time. Space-time is the 4-dimensional fabric of the universe, where space and time are interwoven. Mass bends this fabric, motion stretches it, gravity flows through it. You are not just moving through space, but through time as well. Space-time is the stage upon which everything plays out, shaped by energy, curved by matter, measured by light. 90. Spectrum. The spectrum is the range of light's wavelengths, from radio waves to gamma rays. Each type of light reveals different truths. Infrared shows warmth. Ultraviolet finds young stars. X-rays uncover explosions. Astronomy uses the full spectrum, decoding the hidden colors of the universe. What we see is only the beginning. 91. Star formation. Star formation happens in cold, dense regions of molecular clouds where gravity gathers gas and dust into new suns. It begins in silence. Slow collapse, growing heat, a spark of fusion. And then, light stars are born from darkness, rising out of dust, igniting time itself. Star formation is creation, still happening all around us. 92. Supercluster is one of the largest known structures in the universe. A group of galaxy clusters bound together. Our home, the Milky Way, is part of the Laniakea supercluster. These are colossal webs, hundreds of millions of light-years across, filled with galaxies like grains of sand. They show the grand architecture of the cosmos, a universe stitched together in filaments and voids. 93. Supernovae. Supernova is the explosive death of a massive star, a brilliant flash that can outshine a galaxy. It spreads heavy elements into space, seeding the universe with carbon, oxygen, iron. Everything you are once passed through a supernova. They are both endings and beginnings, cosmic fireworks of destruction and rebirth. 94. Telescope. Telescope is an instrument that gathers light from distant objects, allowing us to see far beyond what the eye can detect. Galileo's first telescope revealed the moons of Jupiter. Now, space telescopes peer to the edge of time. A telescope is not just a tool, it's an extension of curiosity, a bridge between human minds and the stars. 95. Tidal forces are the result of gravity's difference across an object, stretching it, squeezing it. They cause tides on Earth and tear apart comets near planets. In extreme cases, they can spaghettify objects near black holes. Tidal forces are gravity's fingerprints, subtle, strong, inescapable. 96. Time dilation. Time dilation is a phenomenon in relativity, where time passes at different rates depending on speed and gravity. A clock on a fast-moving spaceship ticks slower than one on Earth. In strong gravity, time stretches. It's not science fiction. It's been measured, proven, and used in GPS satellites. Time is not fixed. It flows differently, depending on where and how you are. 97. Transit occurs when one object passes in front of another from our point of view, like a planet crossing a star. We use transits to discover exoplanets. A tiny dip in starlight reveals a new world. Transits are brief alignments, moments when light is dimmed and secrets are revealed. It flows differently, depending on where and how you are. 98. Triton is Neptune's largest moon, a frozen world with geysers, retrograde motion, and a surface sculpted by ice. It orbits backward, suggesting it was captured long ago. Triton is cold, distant, strange, and possibly hiding an ocean beneath its crust. Even the outer solar system holds mysteries waiting in the dark. 99. Ultraviolet light lies just beyond visible violet, a short, energetic wavelength that reveals hot stars, young galaxies, and stellar nurseries. It can't be seen with the naked eye, but it burns, shapes, and traces. Ultraviolet is the glow of creation, and sometimes destruction. 100. Universe. The universe is everything: space, time, matter, energy, laws, and the unknown. It's expanding, evolving, and ancient. It began in fire. It will end. Somehow, you are part of it, born from stars, living on a pale blue dot. Thinking about infinity, the universe is not just out there. It is also within you. You've just traveled through 100 terms, but what you hold now is far more than a list. It's a language, the quiet vocabulary of the stars, from galaxies and gravity to neutrinos and novas. Each word was once a mystery, now softened into meaning. Now yours. You've walked among particles and planets, theories and thresholds, spectra and silence. Some terms came from ancient skywatchers. Others are born of equations and telescopes that orbit in silence above us. Together, they form a constellation of understanding, a guide for any curious soul looking into the night. This was never just a dictionary. It was a compass, because to truly listen to the cosmos, you must first learn how it speaks. Its grammar is gravity. Its verbs are motion. Its pauses are black holes. Each term you heard tonight is a kind of key to unlocking the meanings hidden in other audiobooks, other voices, other journeys across the universe. So when someone speaks, or cosmic inflation, or the event horizon of a star's final breath, you'll know. You'll feel the shape of the word, like the orbit of a thought around a quiet sun. These words are now part of your internal universe. They live behind your eyelids when you dream of the stars. They echo gently when you look up and wonder, and if one day you forget what perihelion means, or why dark matter refuses to be seen, don't worry, because the universe doesn't mind repeating itself. It whispers in photons. It signs its name in planetary rings. It folds its stories into auroras, comets, and collapsed cores. And as long as you keep listening, as long as you keep wondering, you'll always find your way back to meaning. So rest now. The words will stay with you in the dark. They glow. This has been your space for Sleep Dictionary. Not the end of a book, but the beginning of every question that matters. And in the vast silence that follows, you are not alone. The stars are still speaking, and now you understand them.